Hello everyone. In today's video, I am going to explain you the next ray diagram. Only we have two ray diagrams for the formation of images in case of convex mirror. It is also known as diverging mirror. First one, object at infinity. Image is formed at focus behind the mirror. Now in this case, second case, object is placed between pole and infinity, anywhere between pole and infinity. Listen it. We have only two ray diagrams. First, object at infinity. Second, you place the object anywhere between pole of the spherical mirror and infinity. Between pole and not at infinity. Between pole and infinity. Anywhere you place the object. Same diagram. You place the object anywhere. Position of the object, remember. Position of the object between pole and infinity. Object position between pole and infinity. In between pole and infinity, you keep the object anywhere. The diagram is saying, okay, as you know children, for the formation of images, we have rules for the formation of images in concave mirror as well as in convex mirror. Convex mirror being a diverging mirror. So, AB is the object. It is placed always in front of the mirror. AB is the height of the object. AB is the height of the object. So, from this object, we need how many rays of light? Two rays of light. So, a ray of light starting from A, incident on the reflecting surface of convex mirror. Convex mirror is a diverging mirror. Its reflecting surface is curved outward, bulging. The bulging side of this curved surface is reflecting surface of convex mirror. So a ray of light starting from A, strike the reflecting surface of convex mirror at D. You can see D at D. After reflection, as it is a diverging mirror, the rays do not actually meet. It appears to have come from focus behind the mirror. This is the reflected ray. Okay, this is incident ray, which is parallel to the principal axis. After the phenomena of reflection, the reflected rays appears to have come from this, you can see dotted lines behind the mirror. This is what? This reflected ray, when it comes out of the mirror, it touches the incident ray. Reflected ray should touch the incident ray. A ray of light incident parallel to principal axis. After the phenomena of reflection, the reflected ray, appears to have come from focus from behind the mirror. We need two rays of light. So another ray of light, you see, starting from A. Okay? Directed toward the center of curvature. We know very well, when a ray of light is directed toward the center of curvature, it retraces its own path. It comes back along the same path. You see, this is the incident ray, this is the reflected ray. Why? Because angle I is equal to angle R is equal to 0. All of you know this very well. So these two reflected rays, this is one reflected ray, this is another reflected ray. This is one reflected ray, this is another reflected ray. So these two reflected rays, they appears to intersect behind the mirror between pole and focus. Between pole and focus, these two reflected rays, they appears to intersect at this point behind the mirror. So the image is formed between pole and focus. So you keep the object anywhere between pole and infinity. Object placed anywhere between pole and infinity. Image is always formed between pole and focus. Whatever may be the position of the object between pole and infinity, in case of convex mirror, image is formed between pole and focus. Object between pole and infinity. Image is formed between pole and focus. Behind the mirror, as you can see, this is in front of the mirror. Image is formed behind the mirror. That's why the rays are not actually meeting. Appears to have come from some other point behind the mirror. That's why as the image is formed behind the mirror, nature of the image will be virtual and erect. If image is formed in front of the mirror, the reflected rays actually meet. That's why we call it as real and inverted. In this case, the image formed is virtual and erect. Nature of the image is virtual and erect. Why? Because the rays do not actually meet. Appears to have come from behind the mirror. That's why the nature of the image is virtual and erect. Whenever you see in the ray diagram, image is formed behind the mirror. Nature of the image is virtual. And it is formed above the mirror. That's why it is erect. Virtual and erect. So, this is the height of the object. This is the height of the image. So, convex mirror is a diverging mirror. It always forms only one type of image. Nature of the image is always virtual and erect. Size of the image, diminished image. Size of the image formed in a convex mirror is diminished image. Suppose in examination, somebody asks you, name a mirror which always forms virtual, erect and diminished image. What comes into your mind? Not concave mirror. Concave mirror also form virtual, erect, but not diminished, magnified. Plane mirror also form virtual, erect, but not diminished, same size. Convex mirror is the only mirror which forms virtual, erect, diminished image. Size of the image, diminish. Height of the image is smaller than height of the object. So whenever in board exam, this question has been asked number of times, this ray diagram. Name a mirror which forms virtual, erect and diminished image. What comes into your mind? Do not confuse with plane mirror, concave mirror. Plane mirror, virtual, erect, but same size. Concave mirror, virtual, erect, one time it formed, but magnified. Convex mirror is the only mirror which forms virtual, erect, diminished image. Concave mirror, virtual, erect, magnified. Plane mirror, virtual, erect, same size. Now I hope you understood about the other diagram we have in convex mirror. Object anywhere between pole and infinity. Image is formed between pole and focus behind the reflecting surface or behind the mirror. These are the properties of image. Where is image formed? When the object is placed between pole and infinity. We have a ray diagram. You keep the object anywhere between pole and infinity. Image will always form between pole and focus behind the mirror. Image is formed between pole and focus behind the mirror. Second property of image formed. Nature of the image, virtual and erect. Size of the image, always diminish. Magnification. You see magnification. When I write magnification, plus 1 by 3. Plus indicate what? Magnification, positive indicate nature of the image is virtual and erect. 1 by 3 means diminished image. Suppose height of the object is 1. Height of the image will be 1 by 2 or 1 by 3 or 1 by 3, 1 by 4. What does it mean? 1 by 2 means smaller than the size of the object. 1 by 3 means if 1 is the size of the object, 1 by 3 or 1 by 2. Size of the image is smaller than the size of the object. This we will get magnification in which case? In case of convex mirror. Always forms, remember, diminished image. Convex mirror always form what? Diminished image. Okay, na children? Now children, let us try to know. Apply Cartesian sign convention for this. Same thing. You will be always in front of the mirror. You will be in same thing as what you wrote in your previous ray diagram. Object distance is in front of the mirror. That's why it is negative. Image distance, PB. PB dash is image distance. That is behind the mirror. positive. Focal length of convex mirror, PF, always behind the mirror, always positive. Height of the object above the principal axis, positive. Height of the image, positive. In Cartesian sign convention, only object distance is negative. Image distance, focal length, height of the object and height of the image are negative. Remember this. In case of both the ray diagrams, object at infinity, object between pole and infinity, Cartesian sign convention remain same except object distance, focal length, image distance, height of the object, height of the image, all are positive except object distance, which is negative. Only PB is negative because it lies in front of the mirror. Remaining all focal length and image distance lies behind the mirror. That's why it is positive. Height of the object above the principal axis, positive. Height of the image above the principal axis, positive. So these are the Cartesian sign convention for object between pole and infinity. So this is a very important ray diagram, children. Please watch this video carefully. Again and again, I will explain you application of convex mirror and some more thing in my next video. Thank you very much for watching this video.